it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Now, what we're looking at here is divisibility proof by induction. Now, all proofs by induction have the same 4 steps that we can see here in the purple box here. And I always think of that stuff you get in the tree, or an insult you might have got back in the day where people called you a sap. So SAP, the S standing for show, the A standing for assume, and the P standing for prove. And then you've got a wee conclusion at the end. So show, assume, and prove. So in all proofs by induction, whether it be divisibility, inequality, or summation, you're going to show that n is equal to 1 is true, assume that n is equal to k is true, and prove that n is equal to k plus 1 is true. And by doing this here layout, you're guaranteed yourself the majority of the marks, even if we can't polish it up and get that wee bit at the end. Anyway, let's get stuck in to divisibility proof by induction. What I would say is probably the easiest proof by induction to have. So if you're lucky enough in the exam, you'll be looking for full marks here. So prove by induction that 5 to the power of n, that's to the power of n, minus 1 is divisible by 4. So we want to show that 4 is a factor of that. So step 1, as we can see there, is show that n is equal to 1 is true. All we've got to do there is horse in 1 for n. And I'm just using that wee backslash or forward slash there just to show that it's dividing by. So show that that is divisible by 4. Work out the left hand side now. 5 to the power of 1 is 5 and 5 minus 1 is 4. 4 is divisible by 4, leaves us with 1, which is true. Now we're on to step 2. The A in SAP is assume that n is equal to k is true, and this is what we always go back to in proof by induction. So we always go back to the assumption. So, like we did in the first step, just simply sub in or horse in k for our n. And as I say, always in this step 2, highlight it, double underline it, put a box around it, because this is what you're always going to go back to in your proof by induction. And then your final step, your step 3, but the most difficult bit here is prove that n is equal to k plus 1 is true. And like we did in the previous 2 steps, sub in your k plus 1. So everyone should get this far. There's no excuse that you could not get down to that line. So you have to be able to get down that far. Now, what we use in this step is shown here on page 21 of our formula book in our rules of indices. What we're starting off with is on the right hand side, a to the power of p plus q. So we're going into reverse. So we're going to split up that 5 to the power of k plus 1 into 5 to the power of k times 5 to the power of 1. When they're joined together, it just means multiplied or times. And then this is the trick in this. So we want to show that 4 is a factor of it. So you want to split up 5 into 2 numbers that add together to give me 5, whereas one of them is going to have 4 as a factor of it. So I'm going to split up 5 into 4 plus 1. The reason I've done that, as I say, 4 is divisible by 4, so there's no point saying 3 plus 2. So if you're trying to show that 4 or any number is a factor of it, split it up into such that the number goes into this new number that you formed up with. Now, when we see brackets, we just simply multiply them out. And what we've got hidden away here is like our step 2, our assumption, our 5 to the power of k minus 1. What we've assumed to be true. The bit that is left over, the 4 times 5 to the power of k, is divisible by 4. So, like I'll give you a wee example. You don't need to write this in your exam. I'll do it in the aside here. So if I had, or say k was to the power of 1, I'd have 4. The 2 4s will cancel, or you can tidy up that top line, and you get 20 over 4, which is 5. So 4 goes into it. Another way we could have done that, 4 into 4. And that'll always apply. So here we see that 4 times 5 to the power of k is divisible by 4, and we've assumed that 5 to the power of k minus 1 is divisible by 4, therefore it's true for all values of n. We've completed it. And that wee last line there, 3 wee dots, meaning therefore true for all values. Any values of n where it's a natural number. And a natural number is just our positive whole numbers. So go back over that for yourself and get a few more questions and work through them But as I say, we've no excuse not to get down to that first line in step 3. So show, assume and prove, think of SAP.